Hello, everyone. Welcome. So today we are going to work on review problems on Introduction to Statistics. This is the first review set, review 1A. So let's get started. Example, in a survey of 100 stocks on NASDAQ, the average percentage increase for the past year was 9%. So here we are talking about 100 stocks out of all NASDAQ stocks, and the average percentage increase in the past year on these 100 stocks is 9%. So what you have to do is we have to answer these two questions here. So the first one is all the NASDAQ stocks. So when we are talking about everything under consideration, that is the population. So all the NASDAQ stocks are population. Next one here, the 100 NASDAQ stocks in the survey. So out of all the stocks here, we are talking about 100 of them that were surveyed. That means it is a part of all these 100 NASDAQ stocks. So the part of the population that is considered under our study, that is called the sample. So the 100 stocks in the survey are sample. So that is sample. Okay, let's move on to next example. Example, classify the following variables as, we have to classify as qualitative or quantitative. And if they are quantitative, we have to state whether they are discrete or continuous. So the first one here, phone number. Although the phone number contains number, the phone number is not actual number because we cannot perform actual operation among the phone numbers. So the phone number is an example of qualitative variable. So this is qualitative. Second, goals scored in a session by a soccer player. How many goals are scored? So if we want to count that, it will be the actual number. So it is quantitative. And if it is quantitative, we have to state whether they are discrete or continuous. So the goal is scored by in a session by a soccer player does not involve decimal number. So this must be discrete. Length of song in a minute, it can be like 2 minutes, 2.3 minutes, and so on and so forth. So it involves pure numbers. So this is quantitative. If it is quantitative, we have to state whether it is discrete or continuous. And if we think of length of song in a minute, it can be 2.3 minutes, it can be 4 minutes, 4.2 minutes. So decimal values are possible. So since decimal values are possible, this is continuous. So this is quantitative and continuous. The last one, nation of origin, it will just be name. So that is qualitative. Okay, so in this example, we learn how to classify the given variables as qualitative and quantitative. And if they are quantitative, we also learn how to identify them as discrete or continuous. Okay, let's move on to next one. Example, for the following, determine the level of measurement. So if we think of level of measurement, we have 4 different level of measurement: nominal, ordinal, interval, and ratio. So we have to identify each of them. For example, if we talk about gender, it is just the name. So this is nominal. If we think of temperature now, temperature can be measured in terms of interval from here to here, from 15 to 20 degrees, so on and so forth. So temperature can be considered as interval. interval. Movie ratings of 1 through 5. When we talk about movie ratings of 1 through 5, we are actually ordering them from 1 through 5. So it involves order, so it is ordinal. Volume of water used by household in a day, it involves pure number, so this must be a ratio. So in this example, we learn how to identify the level of measurement for the variables given. So there are 4 levels of measurements: nominal, ordinal, interval, and ratio. Okay, let's move on. So in this example, let's see what we are asked to do. Example, identify the sampling technique used below. So we have to state the type of sampling method used. To check the accuracy of machine filling coffee cups, every 5th cup is selected and the number of ounces of coffee is measured. So here, every 5th is selected. So systematically, every 5th cup is selected. Meaning of that is, this sampling technique that is used here is systematic sampling. Systematic sampling. Next one, in a large school district, a researcher numbers all the full-time teachers and then randomly selects 30 to be interviewed. So out of all teachers, everyone is numbered and then only 30 are selected randomly. So that means this technique that is used here is called random sampling. Random sampling. Okay, let's move on. Example, in an introductory statistics class at CCA, 10 students scored the following in their midterm exam. Create a stem and leaf plot to represent the data. So if we look at the data, we have 2 numbers in 70s, 1, 2, 3, 4 numbers in 80s, 3 numbers in 90s, and 1 is exactly 100. So if you want to draw the stem and leaf plot, what we do is for 70s, we write 7, for 80s, we write 8, for all numbers in 90s, we write 10, all numbers in 100, we write 10. And then we draw a vertical line like this. We have a 76 and 78, so 7, 6, 76, 7, 8, 78, 7, 6, 76, 7, 8, 78. That's what we do. For 80, we write 8, 0, so like this. And then we have 83, so 8 and 3, 83, then 88. We have 2 of them. 90, 9, 0, 90, 9, 2, 92, 9, 4, 94. 90, 92, 94. Now, the last one here, 100, here is a 10. In 100, we write 100, so 10 is there, so other 0 should be here. So this diagram that we create here, this is the stem and leaf plot. We use stem and leaf plot to represent the distribution of a small data set. Next one now. Find the population standard deviation for the following data using detailed calculation. We have to show all work and we have to find the population standard deviation. So here we are looking for population standard deviation. Formula to find the population standard deviation is this one. Sigma is equal to square root of the sum of f times x minus mean quantity squared, all divided by the population size n. So that is the formula. So first we need to find the mean, and to find the mean, what we know is, let me write here. We have mean equal to sum of f times x divided by n. That is a formula to find the mean. So what we need is, here we have x, we have f, so we need f times x. So first we are going to make a table. Let's make a table first. So we have x values as 2, 4, 6, 8, 10. We have frequency as 4, 2, 3, 2, 5. Now to find the mean, we need f times x. So we multiply these two numbers. 2 times 4 is 8. 4 times 2, 8. 6 times 3, 18. 8 times 2 is 16. And 10 times 5 is 50. And we add them. So let's find the total. 4 plus 2 plus 3 plus 2 plus 5. That is a total of 16. So n is equal to 16. If we add f times x, 8 plus 8 plus 18 plus 16 plus 50, that is 100. So the mean will be sum of f times x, we got 100, divided by n, the value of n is 16. So 100 divided by 16 is 6.25. 6.25. That is the mean. So once we know the mean, we can find this quantity, f times x minus mean squared, and we have to add that. So here in next column, we are going to find f, this one, f times x minus mean is 6.25 squared. So we have to find that for each line. So in the first line here, our f is a 4. 4 times x is 2. This is our x is 2 minus 6.25 squared. And if we simplify this using calculator, it is 72.25. 72.25. Now let's go to next line. Our f is a 2. So it is 2 times x is 4. So 4 minus 6.25 is squared. That will be equal to 10.125. Similarly, if we go to third line, frequency is 3, x is 6 minus 6.25, quantity is squared. And if we simplify this, we'll get 0.1875. In next line, frequency is 2, x is 8, then minus 6.25, quantity is squared, which is equal to 6.1250. Now the last line, frequency is 5, x is 10 minus 6.25, quantity squared, that will be equal to 70.313. 70.313. So these are the different values. Now what you have to do is, you can see in our formula, there is a sum of all these. So if we add all these, let's see, 72.25 plus 10.125 plus 0.1875 plus 6.1250 plus 70.313 is exactly 159. So once we have this, we can plug into this formula and find the standard deviation. So standard deviation denoted by sigma is equal to the square root of, I've already written the formula here, so I'm just going to plug in. For the numerator, sum of f times x minus mean squared, we got 159 divided by n. N is sum of all frequencies, which is 16. And that is equal to, if we simplify this using calculator, it is 3 3.1524. So the standard deviation for the data that is given here is 3.1524. Remember, this is population standard deviation. If it was sample standard deviation, formula will be a little bit different and the result will also be different. Okay, now let's move on to next problem. Example, monthly Excel energy bills in Aurora, Colorado are normally distributed with the mean of $250 and standard deviation 50. We have to answer these two questions. So first, what we know is the monthly bills are normally distributed, mean 250, standard deviation 50. So first we are going to represent this using the normal curve. So we are going to draw a normal curve and represent the data. So let's do that over here. What we know is the mean, which goes in the middle, is 250. So we are going to write that in the middle, 250. This is a normal distribution with a mean of 250 and standard deviation 50. So now if we go one standard deviation up, let's see where we'll be. When we go on one standard deviation up, it will be 250 plus 50. That is a 300. Two standard deviation up, that will be 350. Three standard deviation up, that will be 400. Similarly, if we go down, one standard deviation down, that will be 200. Two standard deviation down, 150. Three standard deviation down, that will be 100. So we can draw the vertical lines at each point here, like that, like this here, like that, and finally here, and also there. Now in first part, what percent of monthly bills are in the range of $200 to $300? $200 is here, $300 is here. So if I want to find between 200 and 300, I'm talking about this one. Okay, I'm talking about this one. And this is between one standard deviation. We're going one standard deviation up and one standard deviation down. So if we use the empirical rule, what we know is within one standard deviation, we'll have 68% of the data. So the answer to the first part will be 68%. 68%. So 68% of the bill is between those two values. That is between $200 and $300. Now let's look at B. In B, we have to find what is the probability. So whenever we are asked to find the probability, we have to change the percentage to decimal. What is the probability that randomly chosen monthly bill is 150 or less? Okay, $150 is here. So if I want to find from 150 to 350, if I just want to talk about the values between 150 to 350, this one, this is within two standard deviations. So all these data will be within two standard deviation, and that is 95%. So we can say, let me write this down. Between $150 and $350, we have 95% data. We have 95% data. So now out of 100%, we have 95% data here in the middle. So the remaining data that is on the left tail and on the right tail, that is a total of 5%. Okay, the data that is remaining on the left tail and right tail, that will be equal to 5%. So these two represent that 5%. So let me write remaining data. Remaining data is 100 minus 5%. I mean, 95% because we have 95% in the middle. That is equal to 5%. So we have 5% data on two tells. So that is the value less than 150 and value more than 350. But what we want is we want the probability that the randomly chosen monthly bill is $150 or less. So if I just want the value on the left, $150 or less, that is half of 5%. So amount of bill that is $150 or less is equal to 5 divided by 2 or 2.5%. But we are asked to write as probability. So probability that X is the bill is less than or equal to $150 is, okay, here is 2.5%. So if you want to change it to probability, we change it to decimal. So 2.5 divided by 100 is 0.025. So probability that the bill is less than $150 is 0.025. So that's all for this review. We'll come with second review later on. But for now, thank you for watching this.